I'm back again with another part of the same chapter. In the previous video, you have seen about the different state of water. In this video, we are going to discuss about the effect of temperature and pressure on the different state of matter. So let us start with part 8. So you all must have seen or observed the dewdrops on leaves in winter morning, or the water being boiling to make hot soup. So all these change involve the change in the state of matter. But what causes the change in state of matter? You already know that the particle of solid vibrate, and those of liquid, they slide past from one another, and gas particle bounce about freely. So this indicates that solid have least energy, whereas gases have the maximum energy. So maybe if we can modify the energy of the particle, we can also change their state of matter. So let us see this through an activity. Here, what we have to do? We have to take a ice cube, a thermometer fitted into the beaker. So let's start heating this beaker. When we start heating, the particle start absorbing the heat energy. So this increases the temperature together. That how temperature changes over time. So let us plot a graph. Here you can see that as the time passes, the temperature of ice increases. In other words, the energy supplies to overcome the force of attraction between the particle of ice. So this will go to such an extent that ice start converted into liquid water. We now call it as the melting. The temperature at which the ice melt into hot water is at 0 degrees Celsius, and this is called the melting point of water, and this is indicated by point A. Right? In general, at atmospheric pressure, the temperature at which the solid start melting to a liquid is called the melting point of solid. So what is atmospheric pressure here? Atmospheric pressure is nothing but it is a constant pressure of air on all objects. Now even now heat is being continuously absorbed here. We observe that the temperature will no longer changes. Strange, right? So where did that additional energy go? This additional heat is simply convert ice into water at its melting point. Note that this happened without changing its temperature. So this heat is called the latent heat. So what is latent heat? The heat energy that changes the state of a substance without changing its without changing its temperature. Right? So this latent heat is indicated by a straight line that you can see in the figure AB. This is the latent heat. You will be surprised to know that the word latent heat means hidden. Right? Here the latent heat is associated with the melting of the solid. Melting is also called fusion. And here this latent heat is called then the latent heat of fusion. Now once the ice melts completely, any further heat energy supplied will only increase the temperature of water. At this point, there is no ice left to change the state. Right? So this is indicated by the straight line. You can see here. The straight line which rises up from B to C. This indicates that there is a continuously increase in the temperature. Because here the ice is already converted into water. Now once again we find that the temperature become constant at C. Now here at C point the temperature become constant. This fixed temperature at which liquid start boiling at atmospheric pressure is called the boiling point. So for water the boiling point is 100 degrees Celsius. Upon reaching the boiling point, heat is simply consumed to change the state of water. And here also without changing its temperature. So it is indicated by the line CD in the graph, as you can see. This again corresponds to the latent heat, since here the heat is absorbed for vaporizing a liquid. So this is called the latent heat of vaporization. This line CD will indicate the latent heat of vaporization. Now when the last drop of water changes to vapor, the heat applies only causes the temperature of the vapor to rise, going all the way point D up in the graph. Now as you can see from the graph, there is no further change in the state of vapor. Now you know that what happens when solid melts and liquid boils. Can we also say that this process are reversible? Of course they are. The reverse of vaporization and condensation and of melting is freezing. Have you also come across the instance that whether solid substance simply vanish into the air? But this is for another time. We'll learn about them soon. So let us have a recap. The state of matter can be changed by bringing about a change in the energy of the particle. Air exerts a constant pressure on object around it. This is called atmospheric pressure. The temperature at which a solid converts to a liquid at atmospheric pressure is called the melting point of the solid. The temperature at which liquid boils at atmospheric pressure is called the boiling point of liquid. Latent heat can be defined as the energy absorbed when a substance changes its state. Latent heat is absorbed when the temperature of the substance becomes constant. The heat required to melt a solid when the temperature becomes constant is called the latent heat of fusion. And in the last, the heat required to vaporize a liquid when the temperature becomes constant is called the latent heat of vaporization. So this effect of temperature and pressure in the different state of matter. We will continue with this again in the next video. Till then, thank you.